So pointers and references are a way to allow functions to change data, whereas normally when you pass something in as a parameter, it cannot be changed. It's not true of arrays, but as we showed last Thursday, arrays and pointers are really the same thing. That's a fairly true statement. But if you pass an int into a function, you're not going to be able to change it and have that change take effect outside of it. So let's go ahead and do that with a pointer and with a reference, and then we will consider that point of the discussion done. A pointer gives you the address of the object of the data that you want to change, and so you have to refer to it in a special way in order to actually change it. You have to use a special symbol in order to change it. A reference, you don't have to use that special symbol. So let's do a C++ app. Boilerplate. I'm going to steal some. Alrighty. Alright, good old boilerplate. So you declare a variable like this. You declare a pointer using the ampersand. Is that right? With the asterisk. I'm going to capitalize these to make these a little bit easier to understand. This is a pointer to the age variable. You want to store the address of the age variable into it so that we can change it via the pointer. You know what, I'm just going to make it asterisk p. You do p is equal to ampersand age. Store the address of the age variable into the pointer. So if you want to change it, you can do so. Star p is equal to 34. Now when we print out age, it's going to say that the age is 34. Even though this doesn't mention the age variable anywhere, right? If you just saw all this from down here to here, you wouldn't see why age suddenly changed into 30. That should be a capital A. You wouldn't see why that changed, but it's because he's got the address of it. It's kind of like I handed Olivia a piece of paper with my address, and I told her to go to my house and write some graffiti on the house. She could do that. She had the address, right? Same thing here. We have the address of the age variable. We're allowed to change it. You can do the same thing inside of a function. Let's run it and prove it. Haven't run it and proved it. Yeah, so the age is 34. Let's write a function that will change the age. Void change age, and it's going to take a parameter, a pointer. Int star p. And so star p is equal to 44. Now when we print the age out, if we pass the address of the age variable in, it'll change it. Let me squeeze my stuff together, take a couple of these things out. Okay. So let's change the age of the variable. I want to pass the age variable in, but I'm going to have to give it a special syntax. This is wanting a pointer. How do you get the address of a variable? Hint, I just did it like on the third line of main. How would I turn age into an address to pass it in to change age? I have to precede it with a symbol. Which symbol? Yep, ampersand. All right, so now print out the age again, and it'll print out that it's 44. Normally, a function could not change the value of age because it's passed by value, it's passed by copy. You get a copy of it. If I handed Olivia a photographic copy of my house and she painted graffiti on it, my house is still okay. She needs the address of it to go really give me grief. I'm picking on you, Olivia. All right, so you see that it changed it. That's how you pass something in by pointer. You precede it with that. Pass the address of the age variable. All right, now we're going to write another version of change age that uses a reference. So, void change age ref, and we're going to say x is a reference variable, meaning that if you pass something into change age ref, it's not just a copy of it, it's the original thing. So somehow I'm going to give Olivia my entire house when I call the function. I don't know how that works, but this is actually a reference to the original variable and not a copy to it. So if I set x equal to 55 and I pass the age variable in, age is now going to be 55.
On both of them?
Pardon me?
On both of them?
When we call this one. So yeah, we need to go and make a call to change age ref. Let's do it right here. Change age ref, passing in the age variable, and let's print it out. And the first time we print the age, it's going to be 55. You see what happened here? We pass the age argument in, but it's actually an address. That's what the ampersand means. X is an address, so it can change that variable. If we just did this, then why are you giving me grief? Just because I haven't saved it or something. Okay. If we did that, if we forgot the ampersand on it, then by the time we got back out here and we printed out the age, it wouldn't have that value. It wouldn't be 55 just because X is a photocopy of the original data. Put the ampersand there, it is the original variable. So X is a reference to the original argument. So in effect, it is the same variable. All right, that's all we need to know about pointers for now. Hope that makes sense. So P is a pointer to a variable. It is the address, so we can change the value of the variable it points to. All right, go ahead and build and run it. If you're getting syntax errors, we need to fix them because we're going to move on to the next topic. So I'm going to put some notes up here at the top. A class is a collection of data and methods, which are functions attached to data that act upon that data. So at the beginning of the semester, we were doing a lot with people's height and weight and stuff like that. You know, we were all fitness fans for a while. So we're going to write a class that keeps track of somebody's name and their height and their weight. And the reason you do that is because then you could keep track of several people's height and weight all at the same time. You know, if we just have one age variable and one height variable, like in our BMR or BMI program, that's it. You can't hold two people's data at the same time. You can only hold one person's height and one person's weight. And then if you do another one, you're overriding it, right? So we're going to make a class so that we could create several different people, and each one with their own height and their own weight. So here's how it works in this language. Very similar for you Java guys. The class keyword, and you give it a class name. I'm just going to give it a clever name of person. Oops, I'm going to put all this right above main to make it easy to call, right? We have too much stuff down here. Okay, so class, person. What is in our class? It's going to have a height, a weight, and a name. The name is a string. The height is an int. So is the weight. Realistically, you should make them floating points so that somebody could say they're 62.5 inches. Weigh 121.9 pounds. They're really precise. Okay. So we have a class called person. Let's create a person. Person Bob. Okay. I'm not getting the syntax right. Sorry. Let me make sure. These variables are not public, so I'm not able to access them. I can't type Bob name is equal to Bob Johnson. That's what I want to be able to do at this point. But I can't. These variables are not public. It's kind of like they're locked in a room. You want to share them with the world, you define them as public. So I'm changing the three variables up here to be public, and then, now what? Oh yeah, I forgot. Difference between this language and the other ones. Not that same syntax. Gotta fix it. The syntax is public colon. And then the variable. And then public colon. But once you define one of them as being public, the rest of them are public until something else changes. So, there we go. Now my Bob can have his own name. He can have his own height. He's, 60 inches tall. And he can have his own weight. Let's make another person. Person Sue. Sue's name is equal to Sue White. Sue's height. She's taller. She's 6 feet tall. 72 inches. Sue's weight. She's also heavier. There we go. So now we have two variables. We can still get a hold of this guy's height and weight, right? We didn't overwrite them. Whereas in our BMR and our BMI programs, if we'd said age is equal to, 60, and then later on we did age is equal to 40, that 60 is gone. But this height, 60, is not erased by doing this one because this is attached to a different piece of data. It's like a data block. A class is like a blueprint, and it is used to build things. It is used to build, data blocks. This is a data block, named Bob. This is a data block named Sue. Let's write a method that will print that person out, and then we will be done for today. A method is a function that's attached to a class. This one doesn't need to return anything because all it's going to do is display the person, And check it out, it's just a function that we're defining inside this class. Oh, by the way, note that little semicolon. That's different than you'll see in Java, for you Java guys. Just a quirk. C++ is full of quirks. Cout, name, followed by this object's name, followed by ENDL. Then cout their height and their weight. Cout, height, this arrow height. This is also different, guys, right? You Java guys are used to putting a dot there after the word this. Instead, you do a dash and an arrow. Take the spaces out. And let's print out the weight. And then just for giggles, we're going to print out a blank line at the end. Can y'all still see it zoomed out to this level? Even the guys in the back? Okay. So after I've defined Bob, I'm going to print Bob out. Bob.display. And then go under Sue and add Sue.display as well. Just scroll down the couple of lines you need to get to Sue. And if we've cooked this all right, we ought to be able to rebuild the solution and run it, and it should print out Bob and Sue along with all of our 54s and 44s and stuff. There we go. Bob Johnson, height 60, weight 120. And if I printed out Sue, we would see her information as well. I hope that kind of makes sense. It'll make more sense as we talk about it on Thursday, and it'll make still more sense when we talk about it next Tuesday. And you guys who've taken 1113 or Java are already used to the idea of classes. If not, if this is your first introduction, that's cool. You'll still get it. So classes are used to represent collections of data. And they can be kind of abstract, or they can be real world stuff, you know. A person really does have a weight and a height and a display, you know, stuff like that. And you could have a point in space, which has an x, y, and a z coordinate. Or if you're a physics fan, you have a vector, which not only has an x, y, and a z component, but also has a direction and an amplitude of that movement, you know. So when people write weather simulators, you know that they have all these cells defined as objects, and they all have these different attributes. How much moisture is in the air at this point? What is the wind? Where is it going? You know, what is the pressure at that point? And they have supercomputers or very fast computers, you know, dedicated to running the simulation so that they can have millions upon millions of cells for really good resolution of their weather predictions. All right. Is this working for everybody? I'm going to go ahead and scroll down and put my call to Sue.display. But then I'm going to scroll back up because this is the good stuff up here that people may have typos on. Yep, so there's Bob, height, weight, Sue, height, and weight. And so we have two different sets of data being carried around in the program at the same time rather than overriding each other. And we could make as many sets of data as we want. We could put them all in arrays. We could write them out to files. So this is object-oriented programming, which we have not really been doing up until this point. All right. Pause. Do walkabout.